So I'll start with the AppSolver mission statement and maybe just start with reading that line. Make open data lakes as easy and performant as data warehouses. Talking to the microphone. Okay. Okay. So when I met Yoni, we both came from a database background. We are SQL people, and we were working with a huge advertising data set. It was a petabyte scale data set. No way you could fit that into an Oracle or something like that. So we needed to go work with a data lake first time. Like we had that experience. And I remember looking at Yoni and saying, do you realize that just took us 30 days to deliver something that we could ourselves do in SQL in 3 hours? And that experience was the inspiration behind creating AppSolver. We basically wanted to have the data warehouse experience, the Oracle experience, but we wanted to have that experience inside of a data lake. So that's how AppSolver got started. And I think that right now we are talking about Iceberg, and we are identifying a very big shift in companies moving into Iceberg. And kind of the fastest way to explain it, so if I would go and talk to an executive in my company that would ask me, why do I need to move to Iceberg? I have Snowflake and I have Databricks and I have like a bunch of different stuff. What are really the reasons? And I would name those 3 reasons. The first is there's just a lot of data out there, and people are spending a lot of time understanding how to store it, how to catalog, how to manage that data, and standards are required. And Iceberg is a standard, and I think that's very important in the world that we have so many different data platforms. The second is cost, and that ties very strongly to the microeconomics that we are all living in. I don't think there are a lot of people in this room that weren't a part or required to do a cost reduction project in the last 2 months. Everyone are reducing costs. That's the #1 priority for everyone. And Iceberg is a way to store data in a way that doesn't create that data warehouse lock-in. So you can basically reduce the cost, choose the cheapest engine that you want, store the data in different ways. I think that the cost reduction benefits of Iceberg are the same as data lakes, but maybe in an easier way to do it. The last is use case proliferation. I don't know, I've asked about cost, but probably some of you have heard that, can I have a new AI project? Can I have a new big data analytics? Can I have a new streaming project? That everyone are trying to do data project. There are so many different requirements. To me, as an Oracle guy that have seen this approach fail in the past, you can't solve everything in one engine. It makes sense that you need to separate the table layer or the data layer from the actual warehouse layer. So that, to me, is a very exciting news that Iceberg brings. So if we have infrastructure in the form of storage and infrastructure in the form of compute, now we have infrastructure in the form of a table. Like this is the third main big infrastructure that we're creating, and that's big news for people that are in data. All right. So why did we earn the right to stand here and tell you a little bit about data lakes? What have we done in the last 6 years in data lakes? And I named those 3 achievements as things that we are very proud of. The first is we do scale. Like we work with very tough data lakes. I don't know a lot of people that have worked with a data lake where you ingest data at 5 million events per second. Everything breaks down. At some point, you don't even find instances of AWS to serve what you need to do. So I think getting to that scale was an effort, and we are very proud of that effort, and that helped us understand data lakes in a much, much better way. The second is getting good performance. So you work in the lake, you can basically get the worst performance and you can get the best performance. It really depends on how you structure your lake. We structure the lake automatically to get the warehouse-like performance, but with the tools that are just pure query engine. We optimize the file sizes, the compression, the partitioning, like all those stuff that databases used to do internally. We do it as part of the ingestion layer, because in a data lake, you, as the customer, are responsible to do that. The last part is the user. We said this all started because Yoni and I worked on a data lake, and it took us a lot of time to iterate. So AppSolver is the platform. If you want to work with a data lake and you want the data engineering skill to be optional, you don't want to spend all your days writing code in Spark, that's something that we have done that we are very, very proud of. So in the last 6 years, we have done a lot of data lake projects. Data lake is the most common target for AppSolver, and that led us to speak to a lot of customers. And those customers identified some things that can be improved in what we are doing, what specifically AppSolver is doing. and specifically what you can do, and generally what you can do with data lake. I think the first and maybe the most common thing that we heard, and Yoni will touch that in his announcement, I really like the fact that AppSolver is an ingestion system, and I really like the performance you're giving me out of data lake tables. Why do I have to buy the two together? Like I can use a lot of things for ETL or maybe ELT. Maybe I'm going to use a DBT or a Spark with Airflow. There are maybe 50 different flavors. I can do ETL. Why do I have to tie myself just to one when there is another problem? How do I manage my data? In AppSolver in the past, we couldn't decouple those two layers because there wasn't a table. Now that there is a table infrastructure, we can go and basically make those two layers separate. So data management can be one and ingestion could be another. That was a big requirement from customers. The second was we are going to ingest, we're going to basically do streaming or batch ingest into a table. But one of my developers, they wrote some bad data, and now I have just a little bit of bad data in my table. How can I go and fix that? When you work at scale, the answer of let's do a full new replication, that's just not going to happen. You can't give that answer and claim you're a company that does scale. So what do they want? They want to do insert, update, delete. It's not a big ask. I'm saying the lake is supposed to be a data warehouse. Insert, update, delete is a minimal requirement, and that's something you can get with Iceberg. The third is standards, and we touched on that a bit before, and maybe I'll explain that with an example. One of the biggest asks we get with data lakes is that I want to do upsells into a data lake. I want to do deletes, I want to do updates, but it completely breaks performance. And because of that reason, and I'm not going to go very deep into that, you have copy on write tables, which we know from databases, and we have merge on read tables. With merge on read tables, you basically write into a table, but your change is not actually committed into the data. You create a side log, and when you have a query, you basically join that log with your data in order to return the right response. That allows you to do streaming ingestion or just ingestion at a very high rate. Now, the way we used to do that in data lakes is that we created a table and we created a view, and basically all the merge on read logic was inside the view. Why did we do that? Because there was no table. Basically, there was no table infrastructure. With Iceberg, you have that table infrastructure, and you have the ability to hide all of that merge on read logic inside your table. This is just one example. There is, as we were doing ingestion, we needed to make decision how to store data, how to catalog data, how to write metadata. There were no standards, so these customers liked what we did, another didn't like. This one had a suggestion. You always needed to explain it. The fact that Iceberg gives you those standards was a very good thing for us as a company because we didn't need to explain it again and again. We could just support the standard. The last thing is performance. Hive Metastore has been around for a very, very long time. There are a lot of performance problems. If you ever try to do thousands of partitions on a table, you've encountered some of those problems. And with Iceberg, there are options to basically go around those problems. I'm not going very deep into the examples, but basically new bits old. That's the logic behind the bullet number 4. All right. So what is AppSolver going to announce today? So I'm going to do the first part. Yoni is going to do the first part. The first thing is, hey, we support Iceberg. That's, I think, kind of the point of everything. So everything that AppSolver supports is now supported with an Iceberg target. And I would say it's kind of the default as well. So in the past, we would create a data lake table as a default. Today, we create an Iceberg data lake table as a default. This is the standard that we have chosen. So if the source is a stream, or if the source is an object store, or if the source is a CDC, CDC change data capture, basically bringing data from relational databases, then AppSolver could basically create the Iceberg table. We call it the zero ETL approach because you don't have to do anything except define your source and your target. You don't need to actually go and write code. The output of for the pipe. And basically, the moment you connect the source, an Iceberg table is going to create, and anything you're going to do afterwards is going to be with an Iceberg table as your starting point. And I'm saying as a starting point because when I'm going to click again, sorry, we're going to go back to this slide. The second thing you can do is basically create additional layers of Iceberg tables. So I'm going to start with the bronze. That's going to be my raw data. Then I'm going to write a little bit of code that maybe is going to do some transformations. And in the end, I'm going to maybe run some kind of aggregation, and then I'm going to create my goal table. And in general, Iceberg is a good table format, but it's not the only database, only table in the world. You can also take your Iceberg table and export the results of that with some additional transformations into other targets. Maybe I want to send it into a Snowflake or to Elastic or some to other databases. We would first, our approach, let's park all your raw data in the lake. Let's do it with the Iceberg format. Let's do some transformation. Let's query the data from the lake if we can. When we finish, let's export what we can't query from the lake into other engine. We wanted to support use case proliferation. That's the way. That's first, but let's first use the lake both as a staging area and as an area you can go and query the data. I'm going to go back one slide to talk about this. I mentioned that AppSolver supports streams, object stores, and CDC as sources. One of the big problem with CDC is that there are a lot of tables that you need to replicate. And what we found out is that our customers were spending a lot of time just writing scripts to evolve columns, to evolve tables, to evolve schemas. Like the source side keeps changing. Usually it's not even in the area of control of the data engineer, just the developers are making some change and then your script break or you need to create new script. And we wanted to solve that problem because we wanted to make the data engineering skill optional if you work with a data lake. And what you see here is what we call a replication job. So those 11 lines of code that you see there can basically replicate thousands of tables. You just define what's the regular expression, what the tables that you want to bring in. All the schema evolution associated with that is going to happen automatically. Plus the monitoring of your replication job, you can start with a huge replication job and then go look at a single table and understand how that table is doing. So today we are announcing support for Iceberg, support for Iceberg with replication job, and support for Iceberg not just for ingestion, but also for transformation, declarative transformation, which you've probably seen in, I don't know, if you work with a database with a materialized view, declarative transformation are a materialized view, and you've seen them in Databricks as Delta Live tables, in Snowflake as dynamic tables. So this is an implementation that works on top of the lake, on top of Iceberg. So that's going to be the end of my part of the deck. Now I'm going to let Yoni review the announcements that are just for Iceberg. So how do I use this? Just forward back.
Okay, so what Oli talked about is kind of like the table stakes. So these are products that we already had, we already supported, and now we added support for Iceberg, which is a complete game changer in the sense that now the intermediate layers of your lake are queryable and they're usable in all the different ways that you would normally use an Iceberg table. What I'm talking about now are completely new products. So these are things that we didn't have before and we're launching today. So the first thing is Iceberg table management. So this is actually a pretty big deal from our perspective because up until today, up until yesterday, when you built a pipeline in AppSolver, you got open source files, you got everything that you could query it externally, but it was slightly proprietary. It was something that, like, if you were to make changes, if you were to edit it, then AppSolver would break or those changes wouldn't be applied. As Oli mentioned before, we're now decoupling the ETL layer from the table management layer. So you can write ETL into any Iceberg table that AppSolver didn't create, and it'll just work. But the flip side of that is that you can also run AppSolver's table management on any Iceberg table, even one that AppSolver didn't create. And this is very cool because table management is a big issue. It's something that's very, very hairy and everyone needs to solve. But at the same time, I don't want that to impact anything. I don't want to break my table. I don't want to pigeonhole myself. Maybe I want to turn it off because I have some other process that's going to be heavy that's going to be running in the background. So having a completely detachable table management service, and when I say table management, it's a bunch of little things. There are a lot of issues that you need to deal with. There's taking small files that were just written and compacting them. There's making sure that retention actually works. So retention is basically saying, I have a week of data, and I don't want to keep more than a week history. So someone actually has to delete these files, though. And if something breaks there, then I suddenly have very large cloud bills. Garbage disposal. Often, like, you make a commit to Iceberg and it fails. And then there are orphan files that nobody knows that exist. And this can add up to hundreds of terabytes of data in large data lakes, which cost you like thousands of dollars. So just making sure that that doesn't happen. And then there are also more advanced things like enforcing sorting or proliferating sorting in your table, improving the compression of your files. So maybe you want to streaming write files that have low compression and then optimize that compression to have better storage later on. So there are a lot of little things that in aggregate, you have to just think about each and every one of them. And now you can just press a button, start optimizing, and it just does it for you. So we're super excited about that, and works on any Iceberg table, and you can turn it on, you can turn it off. It's not going to change compatibility at all. So that's the first thing that we're announcing, and we're super excited about it. And that button did something completely different. It's like, you're supposed to do one thing. And OK, I have two buttons. OK. Oh, well. All right, so the next thing, which hopefully we'll be able to get to slide 31, and I'll show you also on the thing, is a new open source that we're announcing, Iceberg Table Analyzer. So Iceberg optimization is great, and I would say every table needs it, but I need to prove that to you. So a lot of people have their Iceberg tables, and they're like, OK, I mean, I run queries, they return in a certain amount of time. Maybe it takes like 20 seconds, maybe it takes 30 seconds. Is that actually good? Is it good enough for me? What gains do I have to get from just against the baseline? So this open source Iceberg diagnostics tool, you basically can run it just from your command line, just install it from GitHub or Homebrew or whatever it is, and run your Iceberg diagnostics, point it to a table or point it to a database, and it'll right away tell you, OK, this is how not optimized your tables are. This is how much gains you can get, both as far as file sizes, as far as scan overheads, because there are a lot of files that are in partitions that shouldn't be, how many partitions you have, et cetera. So this is kind of giving you a high-level overview. And you can easily run this on an entire database or all your tables, and just understand where the hotspots are, where are the things that actually require optimization. And these are the places where you're going to want to get started and optimize with Upsolver or with any other tool that would allow you to do that, or manually. So we're very excited about that. I hope that whoever has Iceberg already and wants to try it out, you can just download it. It's available now, and run that and see what the results are. So that's it as far as product announcements. Again, very excited for the product and Iceberg, and very excited for this conference. So I hope everyone enjoys themselves. Oh, great. And does anyone have any questions? Good.
If you really are doing 5 million events per second in Iceberg, how are you dealing with the data fragmentation and stuff that are going to happen with Iceberg?
So 5 million events per second is quite an extreme use case. And so things behave a bit differently. You don't have small files, you have many large files. So there's a lot of, let's say, most of the optimizations that you would do for a table that's at a lower velocity are going to be applied differently to tables that have this volume. But I mean, basically, the query clusters just get a lot bigger. S3 does support it. I mean, there are some optimizations on S3 as well in order to make sure that you can get a lot of reads in parallel. But essentially, you're scaling up the clusters that are reading it. And some of the optimizations become less important, but some become a lot more important. So for example, if I'm writing files at 5 million events per second, so I'm writing like, I forget what it is, but like maybe a few gigabytes per minute, or no, more than that, maybe 10 gigabytes per minute. So I'm writing, let's say, 20 files that are 500 megabytes. And writing a file like that takes 5-10 minutes. So maybe I'm going to want to write smaller files in order to get the latency down, but I'm going to use a very inefficient compression because I just want to get the data out there. And then I'm going to have to go back and recompress and be very efficient in that compression because the data lake is huge. And even like a 10% difference is going to cost me a ton of money. So the optimizations you do are quite different. But in the baseline, the platform supports it and the infrastructure supports it. So S3, Iceberg, and the query engines all support these velocities. They just need to be tuned a bit differently. Anyone else?
Is that for append only or?
In that use case, it's in the 5 million events per second. It is append only. You could conceivably do that with updates as well, but I wouldn't say 5 million updates per second. Probably that would be challenging. But like you could have 5 million events per second append and some updates like to a certain velocity, and it would probably still work. But our use case, that one is append only. Anyone else? All right. Thank you very much, everyone.